Seventh graders, our first lesson in our pre-algebra book is introducing these terms, variable and expression. And so what we're going to be talking about is how are variables used in math and what an expression is. Okay? What if you saw something like 3n? What does that mean? Nate?
3 times n.
Means 3 times n. How did you know?
Because it's up there. It tells us what it is.
Oh, okay. So it says don't use x for times, so you got an idea that that's regarding multiplication. What about the dot? What is that? Read in?
It means times.
Yeah, the dot is used for times instead of the x.
Because if we use the x, then it will look like a number.
Right, exactly. So we got to change your thinking a little bit and not use the x for times anymore. In fact, I wish they'd just get rid of it in the lower grades. Just get rid of the x and just use the dot. Or even parentheses. Because what do parentheses mean? They also mean multiply. If you see a number next to parentheses, it should tell you to multiply the two. Okay? So you can write multiplication that way. Now, all of these are using variables. So what is a variable?
A letter that stands for a number.
Yep, it's a letter that stands for a number. Why don't they just use the number? Because it's called algebra. Right, because you normally don't know what the number is, or we're trying to find an answer if we put a number in. And so in that case, this y could stand for any number to infinity.
And beyond.
Yes. So we use a letter because we want it to stand for any number that we choose. Okay, that's oftentimes how why letters are used. Think back to our geometry unit that we just finished. All those formulas that we studied, like length times width, L times W. Okay? You use the numbers for L and W depending on how big the sides are of the rectangle. Or you learn how to find the area of a circle. Pi times the radius squared. Well, the radius can be any number depending on how big the circle is, right? So we use a formula, R, to stand for whatever number the circle gives us. Okay? That's how that's why variables are used in algebra a lot. Because we want to be able to find the answer or use a formula to find an answer no matter what the number is we're starting with. Does that make sense? So, let's look at some other types of expressions. Expressions is a math phrase. So there's addition expressions, there's ways of writing addition, there's ways of writing multiplication, and there's ways of writing subtraction and division. We're going to talk about those. Look at page 4. First of all, if it doesn't have a letter in it, let's say you've got just this expression. This is a math phrase. It means 5 minus 5, right? I've been reading that since you were in first grade. 5 minus 5 equals 0. So that just has one answer. And what we call this, and so add this to your notes, this is called a numerical expression. This is just a numerical expression. So write down that term. Because it doesn't have any variables in it. If it has a variable, like n minus 5, then it's in algebraic. Oops. algebraic expression. Oops. So it has a variable in it. Sometimes it's even called a variable expression. Okay? Go to page 6. Let's look at some other examples. Oftentimes when you're given a problem in algebra, it'll give it to you in words. So like number 7 just says 16 more than m. 16 more than m. So those words more than tell you something. They tell you the operation you're supposed to use. So if you translate those words into a number or algebraic expression or variable expression, what does more than mean?
Addition.
Addition. So how can we translate that to an addition expression? Number 7. 16 plus m. Now read it again and look at which is the quantity that's given first, or what does it mean as far as what amount are you starting with? Are you starting with m or are you starting with 16? Read it again. It says 16 more than m. So then you have two quantities, 16 and m. Which one do you have and which one are you adding? Everyone think about that. Liv, you want to?
Yeah, you have m and you have the plus 16.
Good. You have m and it says 16 more than m. So you have m and you're adding 16 to that. So m plus 16. In this case, it tells you the order that you should write it because it's telling you when you have m of something, you have m marshmallows in a bag. Does anyone know how many marshmallows are in a bag?
30.
Me either. M. We have m marshmallows, and then you find another bag that's already opened, and somebody ate a bunch of them, and how many are left in there? 16. So now you have m plus 16. You have 16 more than m. So you counted the ones of the bag that were open, but you knew your mom would be mad if you opened the bag that wasn't open and you counted all of those.
Good job.
Okay? Good job. See how those math expressions can apply to the real world? This is real life here, people. All right, 6 divided by z. 6 divided by z. How can you write a division expression? What are some ways to write division? 6 divided by z. Raiden?
Use fancy whatever.
A fancy what?
Thingy. I don't know. The half square, the little curl. Yeah. The fridge. The fridge.
Oh, okay, sure. 6. Well, it's not that one. That's the radical sign. 16 divided by z. Okay, good. Yep. This one is the dividend. Oops, I'm sorry. We're supposed to be 6, not 16. 6 divided by z. This is the dividend. This is the amount we're starting with. The starting amount in a division problem is called the dividend, and then the number that tells you how big you're making the piles. Like if you have a big bunch of marshmallows, or z, let's see, you have a whole herd of zebras, and you're going to divide them up. then you would divide them. This is called the divisor, isn't it? Oops. Okay, dividend and divisor. What's another way to write division? Tate?
2 dots in a line.
2 dots on a line. 6 divided by z. Another one. Okay, just wait, I'll get to you. It's another way to write division.
There's another symbol for it. Yeah.
Yep.
Oh, it's a line.
Yeah,
Oh, yeah.
it's the fraction bar. The fraction bar means division. Okay? So this is a way to write division. And this is a way that you will see it a lot this year when we're doing pre-algebra. Okay? It is written as a fraction. This means divide. Divide the top number by the bottom number. This is the dividend. This is the divisor. Okay? Last one. There's one more. It's related to this, but it doesn't look exactly the same. You know, Raiden, or you just have a question? Oh, you know. Okay.
A ratio. Right?
Not.
Because you said that the.
You mean like this?
Yeah.
Yeah, it doesn't. It's not usually written that way in an expression. What this does is it specifically compares these two amounts when it's written this way. Okay? So 6 parts of something compared to z parts of another thing. All right? So this is specifically used for comparison. But,
It's like a line
yeah,
that way.
like this, the slash.
Slash.
Yep.
That has
6/z. That could also mean division. So you might see it this way. This means division, okay? Now, Raiden, question.
Wouldn't the z go inside because it could be any number, big or small?
No, specifically this says 6 divided by z in number 8. And so it tells you then the order that you have to use, okay? It tells you the starting amount is 6, and then we're dividing it by z.
Okay.
Yep. Okay. Now the order is important, especially with division, and especially with one other operation. Andreas.
Subtraction.
Yes, subtraction. Okay? The order is not as important for multiplication and addition. Why not? What property says that you can reverse the order of the numbers and get the same answer? What property is that? There's a math property or math rule that says you can reverse the order of the numbers. Liv?
It can be multiplying or adding.
Multiplying or adding, yep, so it applies to both multiplication and addition. In other words, like 3 times 4 is the same as 4 times 3. What property is it? You got it?
A communicative.
Close, commutative.
And there's a.
The commutative property.
And then there's
Yep.
a.
Associative. Yep. But that says, the associative says if you have 3 numbers and they're all addition, then you can add the first 2 and then the third one, or you could add the second and the third one and then add the first one. So it's a little bit different that way. As long as they're all the same addition, as long as they're both adding or both multiplying, then you can multiply or add them in a different order. Okay? So here's what I want you to do. I want you to practice translating these word expressions to variable expressions and do 9 through 33. 9 through 33 on page 6. Okay? We did 7 and 8 together, so I want you to do 9 through 33.